So, for you to be able to identify salts, look at the things you must look out for in a chemical equation. Look at all these salts that are here. You will notice that there is no H. Look at this place. No H in NaCl. That is sodium chloride. No H in KCl. K is potassium chloride. No H here. That is potassium tetra. 4 means tetra. O is oxo. S is sulfate. Potassium tetraoxosulfate. This one here, CaCl2, also no H. So that is a normal salt. Normal salt means all the hydrogen has been removed. All the hydrogen ion. No hydrogen ion there. No OH there. No hydrogen ion. So nothing to identify it as an acid, nothing to identify it as a base. That is what we call normal salt. Let's move to the next type of salt. Acid salt. If you look at all these salts now, you will see H. There is still presence of H. Not all the H were removed. Look at H here. This one is sodium hydrogen tetraoxosulfate, potassium hydrogen tetraoxosulfate, calcium hydrogen triazocarbonate 4, sodium dihydrogen tetraoxophosphate 5. So these ones, they still have H. Not all the hydrogen has been removed. So that is what we call acid salt, because hydrogen is actually the identity of acid. The third type of salt, basic salt. You will notice that there is CaOH. There is OH there. That OH there shows that it is a base or an alkali. Let's say base, just base, basic salt. OH there, basic salt. OH here, basic salt. So this first one is calcium hydroxide chloride. Second one is calcium hydroxide triazonitrate 5. The third one is magnesium hydroxide chloride. So all those ones, they are basic salts. They still have OH. So that means not all the OH has been removed. So the fourth one, double salt. Wow. There's one key secret of identifying double salt. What is that key secret? K. Can you see it? K is here. K is here. Al is here. So for double salt, you will see two positive ions. Two positive ions. What's the ion in this first one? K and Al. Potassium is positive. Aluminium is positive. The second salt there, you will see Fe. You will see Fe. Look at it. Fe. Then you will see NH4. Fe and NH4. Both of them are positive. So you will see two positive ions. That shows that it's a double salt. So two, double. This third one here, calcium and magnesium. Calcium and magnesium, there are two positive ions. So that's a double salt. And the third ion there is always a negative radical. Like CO3 now is a negative radical. This one, SO4, you can see SO4, negative radical. SO4, negative radical. So you have two positive ion and one negative radical. So the last type of salt now is what we call complex salt. This one can be confusing sometimes. You can mix it up and think it is a double salt. But how do you know it is not a double salt? Watch me. You will see this bracket. This thing here is always almost there. This thing that looks like a bracket is always almost there. So that's one. They call it coordination. They form coordination complexes. Are you getting me now? So this metal, there's always a metal that is at the center. Like this one here now. This copper is a metal at the center. It will now be surrounded by negative. Look at the NH3. How many NH3 do you have here? 4. So those NH3, those negative ions, those negative molecules there, they call them ligands. So which means complex salts have a central metal ion and a ligand. A central metal ion and surrounding ligands rather. Central metal ion and surrounding ligand. This one has ion as the central metal ion. Then it has surrounding ligands. What are the ligands there? You can see CN6. So that's how they always look like. You will see it. And another thing you will notice is when they dissolve in water I'm talking about how they behave in water. When these complex salts, when they dissolve in water, they don't dissociate. They don't dissociate into their ions. Rather, they remain intact. They remain intact. They don't dissociate. Thank you very much.